Okay, let's get started. Some of you might know me. I've done a few presentations at the Java Forum. I've had another hat on during that time, so I used to work for Red Hat. But as you can see, things change. I work nowadays for a company called CloudBees, and I'm working on something which is called Jenkins X, which is a cloud-native, event-driven CI/CD system based on custom resources. Very long. I'm happy to kind of maybe have and talk about this at another time. Today, I want to talk about applications, containers, and container orchestrators, applications at scale. What are the pieces you need to kind of build applications at scale, and how do they fit together? And also, I want to try to kind of look a little bit under the hood, kind of explain some of the technologies behind these kind of things. The reason I want to do that is all these kind of things, containers, container orchestrators, service meshes, you can build fantastic applications with them, but it's always a trade-off. In the end, these are abstractions helping us to build certain types of application, but all abstractions are leaky. So any project comes to a situation where you hit the bug, it doesn't work, you need a feature which you can't solve with the abstraction or API you're kind of given, you have to kind of go down a few layers. And if you are then forced at such a point to, oh, how does this work? How can I do something different? How can I change the routing in Kubernetes? All these kind of things. It might be too late, or you might be too time-pressed to do it at that time. So I think it's nice if you kind of work with certain technologies, you don't have to understand them in full when you start, but take the opportunity at certain times to, let's do a little bit of a deep dive. Let's try to understand the technology, because it really helps in many situations further down the road. And besides of that, I'm a nerd, I'm a geek. I just like fiddling. I want to know how things work. Okay, let's talk a little bit about let's start. Who is using Docker in production? Oh, that's 2/3, a little bit more. Who's using Kubernetes? Gee, that's also half. So that's good. Let's talk about the first building block of a containerized application, a container. What is a container? A container is a process running on your host, on your machine. It happens to be that this process thinks it owns the machine. It's maybe the only process running on the machine. It has its own user space. It has its own network stack. And it basically thinks it controls the whole machine in terms of memory and CPU. But in reality, it's kind of constrained via software like C groups, and it can only see a limited amount of CPU and memory. I want to compare these kind of the classical model, having virtual machines versus the container world. In the virtual machine world, you have your hardware, you're running your kernel or operating system on top of that, and then you're running another piece of software, which is a hypervisor, which simulates another piece of hardware, on top of which I can install another operating system and then my applications. And the container world, that's different. We have the hardware, we are installing the operating system, and then the processes or the applications are basically just processes on this machine. And I guess this shows also a couple of things very easily. First of all, that kind of explains why containers are faster than virtual machines or more resource friendly. So they're using resources more efficiently because there are less layers of software to run through for an application to run. There's also, like, if you think startup time, there's just less to kind of configure and start up before your application runs. But at the same time, it shows also maybe some disadvantages. For example, security. If my kernel is compromised, if I don't take care about security of my container host or my Docker host, then all my applications become vulnerable, which is not necessarily the case in the virtual machine world. And the other thing is, these applications, they must be Linux, or like, if you're talking Docker, they need to be Linux applications because they're actually running on this operating system. There is no way to install a hypervisor and simulate Windows and kind of put your Windows application on top of that. So these are kind of the differences here. I guess everyone kind of knows Docker. but just a few words. So all this technology around containers, that has been around for a very long time, even long before Docker came around, and companies like Google and co, they were using their own wrappers around C groups and all these kind of things. What Docker really did, I think in 2013 when they came out, is like, they took away the need for configuring all these namespaces, C groups and stuff. You didn't have to care about that as a developer. You just go Docker run. It has this whole API, Docker run, stop, remove, this API to manage your containers. And it had this API, the Docker file to build your containers. And then this really nice overlays file system, which basically meant containers are basically layers composed of layers which are immutable. So I can start a container, it's always the same state, and I just put a little read-write layer on top of that. And that, I think, that was what Docker did. It kickstarted this whole, everyone wanted to containerize applications suddenly. Before that, it was the big companies who had the ops experience to kind of pull it off with their own custom scripts and tools. But Docker opened the door to, let's do this kind of containerized thinking in the wild, like for anyone. Okay, so when I started using Docker, I was purely using it as a development tool. I was working, for example, on Hibernate. I would need different versions of a certain database. I would need different versions of the JDK. And Docker was an easy way for me to use that without having to install it on my machine all the time and cluttering my machine. So that was easy. It was a no-brainer for me to adopt Docker as a local development tool. And then this whole kind of microservices kicked off, containerized application kicked off, DevOps movement kicked off. And then everyone thought, yeah, we have to build applications which kind of run containerized in production. And there suddenly you have a very steep learning curve because you need Docker alone, a container, is not going to cut it if you want to take your application into production. There are many other pieces which have to come together. There's also part, I mean, these are kind of a lot of technical aspects, and I will cover a few. There's a whole cultural change, and that kind of goes into what Jessica was talking about today. Buying tools like Kubernetes and yeah, let's do DevOps. All this is lip service. If you cannot change how your team works, and if you cannot apply the right techniques to use this productively, it doesn't matter what tools you buy and use. It will always fail. I myself was in a project. We did it all. We had meetings to pre-start the project with, we do Agile, we do Accelerate, we do the full Monty. And we're using Kubernetes, and we kind of, each commit is a rollout to production. It went miserably wrong. And it was nothing wrong with the technology. It was a pure people problem. Within the developers and the management, many things come together there, but without the people, you're screwed. Anyways, so we have the single Docker container which helps us package our application so that it's kind of immutable. It's a container. I can run it on kind of any Docker host or any container orchestrator. But then you have to kind of start thinking about other things. If I have an application, and now kind of this whole microservices thinking comes in. It consists of more than a single application. I have multiple applications which kind of talk to each other. How do these services or how does this application find each other? How can they talk to each other? If I have them running in production, if I want to do an update in production, do I have to switch them out all at the same time? Can I kind of just redeploy a single one? How do I get all this working? So that's rolling deployments, network. How do I make config changes to all these kind of things? I have some demos too, but I skip a few to have more time with service meshes later on. Kubernetes. So a lot of these things are like when it comes rolling deployments, service discovery, config changes, that's where container orchestrator come in. And the gold standard here is Kubernetes. There's just no denying it anymore. There are others, like when the whole market started, there was Docker Swarm, or there is still Docker Swarm. We have Mesos DCOS or something, whatever it's called. We have some outsiders like HashiCorp Nomad. But Kubernetes is, when it comes to container orchestration, the gold standard, which every other tool has to kind of measure itself against. Anyone using a container orchestrator which is not Kubernetes? Ah, yeah? Which one? Here we go. And what was, which one? Oh, okay. So I don't know anything about either of them. I swarm a little bit. The Marathon, I have no idea. Anyway, so the gold standard is really Kubernetes. And now I have to kind of say a couple of things. So I love Kubernetes. I write software for Kubernetes. But often it feels for me it's like Kubernetes, microservices, DevOps. It feels like this picture here. That's a picture of the ship leaving to the Klondike gold rush, end of the 1900s. Like everyone wants to go, but very few of these people stroke gold in the end. And I think that's the same with Kubernetes and microservices and so on. I have people coming up to me it's like, yeah, you know, you're doing Kubernetes, and we decided we want to go containerized as well. We want to do Kubernetes. And I go like, why? Is this not what you do? And it's like, if you don't know why you need a container orchestrator, you most likely don't need one. These kind of things are abstractions. They're adding costs. They're adding, and also like certain things maybe become easier. Like everything, it's a microservice, so the microservice becomes easier. But now I have 50 microservices which I have to kind of let talk to each other. So I'm putting the complexity away from my code into how do I manage the infrastructure? How do I monitor the infrastructure? How do I trace a bug? How do I reason about the code? It's very easy to reason about a monolith, right? Now you build a WAR file, one single big jar, everything, the whole source in one repository, super easy to reason about. A microservice distributed over 50 different services, clustered in how many, 10 nodes, very hard to reason about. So no, it's all good, but you have to have your reason to do containerized development and to go to Kubernetes. The other thing, my second advice would be, if you don't have the experience in-house, like good operations, start off with a hosted Kubernetes offering. The beauty about Kubernetes is it's available natively on any of the big cloud providers, Azure, Amazon, Google Cloud. They know how to run Kubernetes, and you probably don't. So that would be my second advice. Don't try to run Kubernetes yourself unless you really know what you're doing. There are a lot of complexities in there. Okay. So I said I want to kind of look a little bit under the hood. Let's talk quickly about the architecture of Kubernetes. There's the Kubernetes master, which you as a developer or operator interact with. And this master, so like you hear often said, Kubernetes is declarative instead of imperative. What's the difference? So imperative is Docker. Like I say, Docker run this container X, Docker run container Y. I'm telling it, this is a container you're supposed to run. Kubernetes works more, I'm describing a state of my application. I'm saying, I want container X to be run in 5 copies across my cluster and container Z in 6 copies. And they should have this and this port open. You're submitting this information in what is called resources, which is basically YAML. So you're sending a bunch of YAML data to this master. And this master, with the help of the controller manager, it looks at the nodes in the cluster and goes like, oh, I have to run X instances of application X in my cluster. How many are running? How many more I have to start? And so on. And it does that by talking to a kubelet. So each worker node in a Kubernetes cluster has a kubelet, which communicates with the master. Then we have pods, which is another abstraction again. It's all like software development is all about abstractions, right? It's always abstractions. A pod is basically an abstraction around containers, and the smallest addressable unit in Kubernetes is a pod, which is one or many containers. And usually, I would say, let's later talk about service meshes, but there you have one container, one pod. That was the classical case. But nowadays, if you're then using service meshes, then you have at least two pods, two containers in the pod, where you have the main pod, which is your application, plus a sidecar, a proxy, which does a lot of nice things, which we are going to talk about in a second. So overall, there are kind of, I think, half a dozen services defined in Kubernetes, which kind of comprise the architecture or like the behavior of Kubernetes. So it's interesting bit that Kubernetes describes what the system has to do, what services it has to provide. It does not describe how you implement them. So there's the default Kubernetes distribution, but then there are other distributions which can be certified, which kind of provide these services in different ways. So one example here is the overlay network. So the overlay network is something, so one of the things Kubernetes describes is each pod or each container in the cluster should be able to talk to any other container in the cluster directly via IP. And obviously, like if you're thinking, like here you have your nodes, and there is somewhere a physical network connection, right? So how do but I have multiple pods running on my node. How can each of them kind of have its own IP? It's only one physical connection there. So then you have to kind of have something which is an overlay network, which is a virtual network which spans across all the containers. And this kind of service can be implemented in different ways. For example, with Flannel, which is the default, or ViVNet, and so on. So now a little bit fun. I talked about distributions of Kubernetes. I want to introduce one. It's called K3s. It's, for me, one of the nicest distributions. I have also, you probably don't see that, I have a little Raspberry Pi cluster with me over here, a 3-node cluster, one master, two nodes. And I want to show you how easy it is, hopefully, to install a Kubernetes cluster. So I'm doing that from scratch. There's nothing on, except of Raspbian, there's nothing on the Pis. So I let this run here for a second. I go back to this picture. Another thing we're seeing here with this, so K3s is a certified Kubernetes distribution, but it's completely built in different ways. So like if you look at the server and the agent, they are single processes. So all the services a Kubernetes cluster has to offer, they are kind of and packaged in a single process. Like on the left side for the master, it's using SQLite. It's kind of the API server, which is in a single process. On the node side, the kube proxy is in a single process. The kubectl, Flannel runs in the same process, and so on. So I would not recommend running K3s in production. That doesn't make any sense in my world. But it's an extremely nice tool to explore Kubernetes because you have all the power you can get. You get root access to the master. You can provision it in Amazon as long as you kind of create 3 instances like virtual machines. You can just deploy it. Now we have to wait a little bit. Now this. So usually, if the network connection is good, it's around 60 seconds to start to get a 3-node cluster. I had it done once in 45 seconds. Any questions so far? We can. Yeah. A little bit the same. The same reason as I would recommend the cloud service. It's a certified distribution. The thing is, a rancher who produces a distribution is not really sure what they want to do with the tool. I think they place it more as experimentation, as maybe something you want to bring up for testing kind of thing. But they're saying they don't have support for K3s. It's not a product they want to support as a product Kubernetes version. So I would take it with a grain of salt. And I still believe for production, I rather let Amazon or whoever run my cluster. But at home or like if you want to just play around, absolutely. So 2 minutes it roughly took now. So let's have a little bit of a look. So I have a 3-node cluster. I install a little application. So we start very simple, and then after this demo, we kind of look at a much more complicated application. So this application is an application with a HTTP front end, which gets a URL. In the URL are two numbers, which are getting extracted by the HTTP server. And then it takes these two numbers and passes it on to an adder service. And the adder service just adds these two numbers together, and then it sends everything back. Right, so as you can see, we're having two pods running now. One is the API, one is the HTTP server, and the other one, the adder, is the service for adding two numbers together. Right, and now I'm kind of just, can everyone read that, by the way, or shall I zoom in a little bit more? All good? So I'm just curling the cluster or like the service, and I'm adding, there is no magic here. A little bit, but not in complexity of this application. Let's look a little bit at the application. So now I just want to zoom in some of these abstractions, some of these things which Kubernetes does, which you maybe should be aware of if you work. Oh, that's the wrong one. Golang here. So this service is written in Go. And zoom in a little bit. Right. So here is the HTTP, or like the API part. And it starts off with reading two environment variables. One is a port and one is a host. And then it goes off to kind of uses gRPC. Anyone knows what gRPC is? Google's remote procedure call framework, which is kind of gaining more and more traction. And it's a remote procedure call, TCP. It's not really so interesting in this case, but it basically gives these two values read from the environment. It kind of connects, opens the TCP socket to this other service. Here we see something like this whole kind of reading things from the environment. So one thing you have to think about when you kind of go to containerized world is this 12-factor apps. Who has heard that? Right? That's. I think if you want to go containers and stuff, you should read up on that. I think it's basically 12 points on how to write portable applications. So, for example, you should not hard code anything in here in your source code. You should always inject the configuration via environment variables, for example, to have this ability to have portable and configurable applications. You want to be able to change this configuration from the outside without having to recompile your code. Let's look now at these resources. Now, I mentioned before, Kubernetes works that you're kind of submitting a resource or like a YAML file effectively describing the state of my application. There are two types, or there are many types, but two are used here. One is a deployment, which is effectively describing which image to run and which port to open. And one is a service, which is, again, an abstraction around what kind of port or what kind of service an application offers to the outside world. So interesting part is here. And these are the two environment variables read in the application code, right? Port 3000, that's trivial. I just kind of apparently chose a given port. But then it says add service as a value for host. So has anyone, I'm sure you guys, anyone using Kubernetes has had that, am I right? You're just specifying a name here. But then how does this actually work? Because this name, we're talking TCP IP, gRPC is TCP IP. So this thing has to resolve to an IP so that I can establish my connection, right? So how is that possible? How can this name resolve to an IP of a pod? Anyone knows? What was it? kubedns, core DNS. So there's another part in Kubernetes which does exactly that. And this is one of the pieces which can fail or fails most often, especially if you deploy Kubernetes on your own machines. Kube and core DNS is one of the things, or a service not responding or not being resolvable is one of the classical problems you can hit in Kubernetes. Especially if you kind of go, oh, I have my own machines and I kind of use them also for something else and I have custom IP table rules on there, but I still want to install Kubernetes. You can get into problems. I thought we have a quick look at that. Let's do that first. Get service -o wide. So here you see the services. We have two services, the add service and the API service, and they have internal cluster IP. If we are now starting a new container, and this, by the way, you can do that in Kubernetes. Now I'm saying kubectl run, which it would be imperatively, and I think I will get the warning, if I'm not mistaken, that this is actually deprecated. No. But this is not the way how you should do it, but you can do it to kind of run like once-off containers. So I have a little container, ns lookup add service. And here I get the IP. So there is something in the cluster as you kind of create services, as you delete services. It needs to keep track of all the services in the cluster and update its state so that it can resolve these kind of DNS queries. And also now, like if you kind of start digging a little bit deeper, how does a node you're starting a container on Kubernetes, and suddenly each container can resolve via NSLookup or dig or whatever, can resolve these services? How can that be? Right, so I guess you guys heard or seen resolved-conf, which is a Linux way to configure your DNS server. And up there you have name server 10.43.0.10, which is a name server of my Kubernetes cluster. And that gets injected. So there are things happening with which are really a little bit magic in Kubernetes. So in this kind of containerized world, you start off a pod. It will kind of, in the Kubernetes world, it will kind of add this name server here. Cool. And this is basically just to show a little bit, there's a lot going on if you kind of go into this world, and a lot of things can break. So I think it's really worth once in a while to reflect about these things and understand how they work, because there comes a time where you have to look at these kind of things. I skipped this one. I want to spend more time on the next things, which is a little bit more interesting. But this is Flanell, which is also like its whole, in itself, a whole topic. If you look into a container or running in a cluster, and you look at the IP tables rule of this container, or better, of the host running the containers of one of your nodes, you would be surprised how many IP table rules are defined in there. It's like massive, and it's a miracle that actually things work as well as they do. Okay, so now we talked a little bit about containers, which help us package things. We talked about container orchestration, which allows me to have multiple containers, and they can find each other, they can talk to each other, they can reach each other via direct IP. So everything is fine, right? I can write microservices now, right? True. So Kubernetes container orchestrators are enabler for microservices. They are enabler for DevOps. No doubt about it. But if you think it comes like that's it, I just take my application, put it in the container, put it in Kubernetes, I'm done. You won't be happy. And the thing which is missing, it's observability. That becomes the cornerstone of any kind of large-scale application now. And observability is logs, metrics, and traces. I want to be able to reason about my system. If I can't reason about my system, I can't fix bugs. I can't find performance bottlenecks. I'm stuck, right? And if you're not building these kind of things, or if you don't spend time building these kind of things in beforehand, or think about how you want to do it, you're ending up with a system. Yes, it runs. Yes, it's containerized. But it's a maintenance nightmare. It's a nightmare to debug. It's a nightmare to just keep running. And this, I speak here again, same project I mentioned, out of painful experience. One other reason this project failed was we thought we had many teams, everyone kind of, you build this, you build this, and you do Go, you do Java, that's fine. It was just a rough API we agreed upon, and then kind of people would just build things without any thought or any agreement on, let's use the same logging structure, how do we centralize the logging? None. And we ended up with microservices, but it was a huge mess. Anyways, I don't want to turn you off from going microservices, by the way, even if it sounds like this. Right, so let's look now at another example application, the hipster shop. And this application is actually written by Google or maintained by Google, and it showcases some of the Google Cloud features, or it uses some of the Google Cloud features, but can be deployed on any Kubernetes cluster, really. And it's, you can look at some products, you can add them to a cart. I want to pay in euros, I place an order, I go back, continue shopping, and so on. If we are going quickly back here, we are looking at the application with around 10, 12 services. There's a front end getting all the HTTP requests, a checkout service, a cart service where I add my items I want to buy. Once I'm buying, there's a checkout service which talks to an email service, to a payment service, to a shipping service, and so on. A microservice, basically. Right. So what are the ways to kind of gain observability in these kind of applications? Who is using Istio, a service mesh? One, right. Here we go. So this application, I installed it with Istio, and Istio is a service mesh. So I thought I'd kind of, again, try to visualize that a little bit. Give me another shell. So now I'm actually connected to a Google Cloud cluster. Right, so that's my development cluster for Jenkins X, by the way. Right. Another nice tool for Kubernetes, anyone who likes working from the command line, from the bash or from the terminal, K9S. I would not go to the console anymore. It's so much nicer with a tool like this. So here I see my pods in the cluster, the services which are making up this hipster application. So if I look at one, you see 3 containers in here. One is already finished and 2 containers running. The server is my actual container, my actual application, and then there's called something which is the Istio proxy. And Istio init is a container which, the idea of Istio is the following. Once my namespace or my project is Istio enabled, I can say to Kubernetes, deploy the server container as in the cluster. Istio will intercept that and go, oh, someone tries to make a deployment. I actually put a sidecar in front of that, this Istio proxy, and this Istio proxy captures all incoming and outgoing traffic. So all connections to this application will be proxied by the Istio proxy. And Istio init is a container which is kind of running first to make sure this kind of proxying can happen. Again, IP table rules and whatnot. So once you have Istio in your system, for each deployment, you kind of want to be Istio enabled. You get a sidecar, Istio proxy sidecar. And once you have that, and imagine that for your whole application, right? For each of your services. Once you have that, these proxies get a full picture of your application. They can measure how many requests are coming in. They can Istio has something which is the control plane or the mixer. There you can do things like canary deployments, blue-green deployments. You can tell this proxy to route traffic to a certain percentage to a certain set of services. so that you have a lot of flexibility. So let's look. Istio nowadays comes with something which is called Kiali, which is a front end to Istio. Come on. Maybe the support forward died. Right. So Kiali runs in the cluster. It's not. I'm not exposing it. So if I want to access it, I actually port forward from the cluster to my local host, and then I'm connecting to this to the UI locally. So hopefully it worked. Okay, good. Admin. Sorry. It's admin. It's the default. So I don't want to save that. Right, good. So here I see all my namespaces in the cluster. The hipster is here. It has 12 applications. And now I want to show a little bit what I mean with applications at scale, ability to reason about the system. Hipster deploys with a load generator. So as we talk, like automatically there's a load generator which randomly kind of looks at products, which randomly puts something into a basket and randomly checks out. So there's always traffic. And then you kind of, we can look at the front-end service. It has a little check, so it kind of says, no, all is good. The service is healthy. We can look at the inbound metrics. We see how many requests per second are coming in. We see the response time. We also see how how big the requests are, and so on. But the real beauty is this thing here. Now, I'm not sure, you might not be able to see that. This is the network graph. Because we have these proxies, Istio can build a picture of the calls going through my system. And now it's actually quite interesting if you start off from nothing. So if you start the application and look at this graph from the beginning, the services would be just single dots on this page. And as you drive traffic through the application, it would kind of connect the dots and go, the front end calls the checkout service calls the currency converter, and so on. So it builds up this dynamically. I thought we kind of do now something like this. So here are my deployments. No. Let's take down the checkout service. So what I'm doing now is I'm manually scaling down to 0, 1 of the services. So if we are now going, for example, to the hipster shop, I hope that if I add something to the cart and try to place an order, it will eventually throw an exception, I think, on the UI. And here again, here's another. You want to do that right, you have to kind of now put things into your code on how do I degrade my service. So now I get an exception. That's probably not what you want in a well-written containerized application. You want to be able to have things like, what was it called, the switches? Someone helps me out? No? Okay. There's a certain pattern which I kind of, by circuit breaker, thank you. Right, so you would like to have a circuit breaker in there so that you kind of get a default response. The service is not responding, you want to kind of, for the user, you don't want to show the exception, you want to show him, at the moment you cannot place an order, we are working on that. Circuit breakers, very good. Back to the Kiali console. And now look at that. So the load generator, we have some problems here, and the checkout service is kind of completely down. So now I get a visualized view of what's going on. Something started to fail, and I can kind of visualize that here. And this is the kind of thing you have to, if you're going down applications at scale, big applications, big microservices, you have to build these kind of capabilities into your software. And otherwise, it's not, it's not going to fly. We can also, this port forward might have died as well. Let's see if I can get. I think that's the last thing we have time for then. What is it called again? Grafana. So Grafana is another, so like how Istio works in this case, it's using Prometheus, which is kind of, again, running something on your container, which kind of collects statistics. And with Istio, all these statistics goes to the control plane of Istio, which kind of then goes to Kiali, but also to Grafana. Anyone using Grafana? Ah, that's Mel. Okay, cool. And here you see Grafana, and that's the front-end service. And you see it was basically all the way up, and these kind of dips here in the service. That's when I kind of took down the checkout service. And do I need both? Yes. So like, if you're looking at this graph, that's a nice visualization. That's no alerts. You want to be, if certain events happen in your system, you want kind of bells to go off. You want someone from PagerDuty to kind of, okay, something is going wrong in our service. That's more where tools like Grafana come in. There you can have defined custom views and kind of alerts and all sorts of things. So here's another interesting point about this one. Again, to the project I kind of mentioned a few times today. So another problem we had is like, people go, but that's easy. We just enable Grafana to collect all these metrics. And yes, right, that's easy to enable. But in the default views, in the default setup, you don't get really useful information. You have to fine-tune Grafana and the alerts and what it displays, how it displays to your application. And that's a skill. Like, it's not, it's Grafana configuration is not trivial. It's a nightmare. And then you kind of get a lot of pre-packaged Grafana plugins, and it kind of, yeah, that's good. It covers 50% of our use cases, but the other 50% are still not covered. And then as a developer, you look at some of the graphs and go like, I actually don't even know what to make out of these numbers. So there's another kind of, it's another set of skill set, another set of complexity. So it's not as easy as, yeah, we just enable Grafana and then we get some numbers and now we have observability. It's about understanding what you're measuring, configuring what you're measuring, and kind of keeping these things up and running. So very quickly, that's for this example, stack drivers, aggregated logging. You want to be able to have all your logs coming into the same source, and then you're kind of up here. I can basically just specify the app and see the logs for a single app or service. Another very useful feature is the profiler, where I basically can. Where is the? So this is the add service, which is written in Java. And you basically can see where the application spent the time. And thread 1 is basically the main thread, so that's not really telling. But you can also see how much time is spent in my main HTTP handler method. And all these kind of things, you might not need all of this, but you have to think of which one do you want and which one makes sense for your use case. Right, so let's go back to here. I'm not going to talk about Jenkins X. So that's what I wanted to show. Like you want to go containerized, going to Docker, easy. Taking the next step, container orchestration, not so easy anymore. Is it enough? No, probably not. You need even more. You need things like, I'm not saying a service mesh, but you have to think about aggregated logging or observability and these kind of things. I think that's all we have time for right now. No, yeah. It would take too much time to kind of get into more things. But some questions, maybe?